Hello, everyone. I'm Ariel Assaraf, co-founder and CEO at Coralogix. This session is going to cover observability in 2022. A bit about myself and the company. I started my career at the 8200 Intelligence Unit in the Israeli Army, later joined Verint for the Homeland Security Division, and founded Coralogix in 2015. Coralogix is an in-stream data analytics platform for logs, metrics, tracing, and security. We help over 2,000 customers worldwide, including some of the biggest brands in the world and some of the leading companies in India, achieve better performance, coverage, scale at much lower costs for the logs, metrics, tracing, and security, and help their companies achieve better customer satisfaction, higher uptime, and better performance. The agenda for today is to, first of all, cover the reason for needing observability. What is observability? What does it mean? What are the pillars of observability? To talk about best practices, how do we achieve observability for our organization the best way? A little bit about alerting and on-call. So how do we respond to incidents as a company without wearing out our teams? How does security and observability unite and become basically the fourth pillar of observability? And a few words on the Coralogix way, why we think that in-stream analysis is the right way to go for observability and security. So observability is the ability of the organization to answer questions on their data. And questions typically split to three different types. Donald Rumsfeld, when the US invaded Iraq, coined the terms known knowns, known unknowns, and unknown unknowns. So when we think about our data and observability and how we monitor and secure our applications, we have the things that we always know that we need to monitor and we always know that they're going to happen. For instance, usage, traffic, volumes. Those are things that we know that are there and we always need to monitor them. So if I want to look at incoming traffic, I want to look at concurrent users, I want to look at CPU, I want to look at memory, I want to visualize them and know the status of them. Those are known knowns. Known unknowns are things that I can describe that may go wrong. So out of the known knowns, for instance, I can describe that if I have more errors than the usual, obviously that's a known problem that I want to track, but it's unknown when it's going to happen or how. So I want to give an alert on that, or maybe I want to track CPU usage or memory to understand if there are issues that I'm not aware of. And the hardest part to answer is unknown unknowns. So issues that I cannot predict, and I cannot predict how they will happen or manifest. Now, in our opinion, in the Coralogix opinion, known knowns and known unknowns cover about 90% of the use cases. Once you have those covered, you typically get to good stability. Answering the unknown unknowns will take you to the next level of actually being able to ask your systems questions that you can answer yourself. So the pillars of observability are logs, metrics, and tracing, like we mentioned. Now let's talk about each and every one of them and see how we can improve it, how we can do it the proper way, and what are the things that we can add to it to make it more proactive. Logs are based off four different types. Infrastructure logs, the machines, storage, and so on. Even network can be considered as infrastructure logs. Application logs, those are custom application logs that we produce. API logs, so any API call, whether it's into your APIs, outside your organization, and so on. And obviously audit and security. So we want to have audit on access, we want to have security logs for logins and so on. Those are things that we definitely want to track. Metrics are three different main types. One is infrastructure metrics. So we kind of mentioned network metrics, CPU, memory, threads, and so on. The other one would be custom metrics that we see as extremely valuable. How do we create business logic metrics? So for instance, if I'm an organization, and Coralogix is an organization that analyzes log records and analyzes metric records, I, as an organization, want to track the time it takes me to process a single event. That'll be a custom metric, but then I want to break it down to a lot of sub metrics under it. how do I process an event per user or per company or per organization so I can get more granular, and we will definitely talk about this more. Tracing is an instrumentation that you create into your app that collects the spans, so the service name, operations, and other metadata that you can add, collects errors, but most importantly, collects the duration of important operations. So specifically in distributed systems and in microservice architecture, you'll have several microservices serving the same request. What tracing does, it adds context in your printing of traces that lets you understand exactly how much time the transaction spent in each and every one of the services. So when you have latency or lag or errors, you can really quickly look at the stream of events and see where things got stuck or where errors were triggered. Now, tracing is a deeper instrumentation. It's not easy to get there, and it's mostly answering unknown unknowns together with log data. We're not seeing many companies still adopting into tracing, but we're seeing that the trend is continuing. Now, let's talk a bit about logging best practices. So in order to achieve proper logging, it's not enough to just send all your data to Coralogix or any other solution that you're using. There are some best practices that you can apply to dramatically improve results, get better visibility, and get better performance. So first of all, you want to log communication between all your internal components. So for instance, if you have several microservices, you don't want to write logs that only talk about what's happening within the service or within the function. You want to monitor and log every connection that happens between a few services. So if I have a Kafka stream and I have a microservice that reads and writes into that Kafka stream, I want to log exactly what was read, what was written back, and any error between them. This way, if you think about a more complex architecture, it's very easy to spot what microservices at a higher level. So if we think of tracing, it talks about a single transaction, but logs give you a higher level of error rates between different services. What are the services that have the most latency and so on? This way you can identify bottlenecks at the more high level of your application. Logging communication with external APIs is critical. So a lot of organizations these days, we rely on many external APIs that aren't in our control. So for instance, if I want to bill my customers, I may use an API with Stripe. If I want to send them an email, I may use an API with SendGrid or Mailgun. And those tend to be very hard issues to resolve or to figure. So for instance, if one of your customers is complaining that he hadn't gotten his receipt via email, you may want to check exactly what it is that you send SendGrid to send out and what response did you get from SendGrid. So not only logging the internal process that produces the email, but actually look at the body that was sent to the external API and see if there's any change in it or if you got a rejection from that external API. Another critical thing is to add valuable metadata to your logs. Logs, if we think about 15 years ago, were built in a very efficient way, like write the least you can, don't overload. These days, logs are very rich. They have metadata that can help you really identify and solve problems end to end. They can talk more about the cluster it comes from, the IP that it comes from, the customer ID or the user ID. You can even add metadata that is related to metrics or other external enrichments. So for instance, a customer can add an enrichment list and convert user IDs to username or customer IDs to customer names. And all this metadata helps, whether it's a support engineer helping a customer or a DevOps engineer or an SRE that is solving a problem. Another important thing that we see many times with some of the customers that we're talking to is a lot of the logs are not very readable. Either they're written in language that only the guy that wrote them can understand, or they are machine-like written without any human context that helps me really read a log and understand what it is. It takes a couple more seconds when you're writing a log to make it human readable and human friendly. And that goes a long way whenever there's a crisis or a need to support someone. And just remember, you may move to another project or one day even move to another company. And also, even if you're there, you may use outsources like external logs and subcontractors to monitor your system, and they're not going to know what you're talking about. They're not going to know exactly if you refer to a specific unit within the organization or anything like that. Everything has to be very detailed and explicit. Make sure there are no typos or misspellings. Now, this sounds, trivial, but we see that small typos can sometimes make investigations so much harder. Most monitoring tools don't have fuzzy search. So if you write error with one R, someone may look for errors during a crisis and just not find it. So just tiny thing that is easy to monitor and make sure that you're doing properly. And combining textual and metric fields. That's something that we saw in some of our clients that is very useful. So log is by nature textual, but you can do two things. First of all, you can add a snapshot of the metrics from that time. So for instance, if there's an error, maybe you want to have a key that talks about the CPU at the error time, the memory at the error time, number of connected users at the error time. And that can give a lot of context and help to anyone investigating an issue or looking at this error. And also you can convert log data to metrics itself. So some of the products know how to take in a stream of data and then convert it to labeled metrics that you can use externally to the logs, also in your metric dashboards. So those are some best practices for logs. And when you define their severity, you can really make it easy for anyone investigating to slice the data into 5 different severities in a way that reduces the amount of data that they need to analyze by an order of magnitude very quickly. So debug or verbos will be just things that happen in the background in your system. We have an example here, for instance, number of messages in user creation queue is something. This is not a message that describes a transaction or an error or anything like that. It just tells us what's happening in the background right now. Once we have that, if we have a crisis, if we have an issue, we can go to these logs and maybe this number will tell us something. So if I have a number of messages in queue is 3,482, and then I see that the processed messages number is smaller than that, and that is accompanied by a few errors, maybe I can relate lost messages. Typically, only when you debug, many users want to store these logs, they want to monitor them, but they don't really want to index them because it's overly expensive and they produce a lot of noise. Info logs will typically be full transactions, user completed sign up, money transaction completed, user invited friend. Those things will be logged as an info log. They tell us the story of what's happening in our system. Warning logs will be small problems that happen in the code run, but they're not affecting the transaction, or they're not affecting the user experience. So if, for instance, an example here, if someone decided to call himself James and you do not accept special characters and you ignore that character. So everything worked as usual. The customer signed up. It's just instead of James, he'll be signed up as Jane. This is a warning log. You want to monitor and track them because if you have many of them, maybe there's something wrong with the UX or your code, and you want to make sure that you're on top of it, but you don't want to call them errors. And we see too many users labeling those as errors. An error log would be the opposite of an info log. So a broken transaction. If money transaction completed successfully is the info example, fail to transact money will be the error that is the opposite of that. Or here we have an example, fail to execute query for a user. This doesn't mean that something catastrophic happens, but it definitely means that for some users, something isn't working. And then it's very easy to filter out errors and look at all the things that went wrong today. Critical logs should be very rare and are describing a critical situation that forces you as an engineer, an SRE, or a DevOps to stop everything you're doing and handle them. And we'll get to that back once we talk about alerting. But if you see too many critical logs, you're probably printing the logs in a way that is not very efficient. So an example here for a critical or fatal log would be no connection to DB, fail to register user. We know that this is catastrophic. We're going to wake up in the middle of the night and solve it. So once we have this understanding in our head of how we split the 5 severities, It's very hard for our users at a glance, looking at a graph, looking at the data that they're querying, to understand whether something went wrong, whether there are more errors or more criticals than usual, or even more warnings, rather than just having logs written without any standard within the organization. And then it's very hard to understand whether a critical is really critical or an error is really an error. When we talk about metrics best practices, the first one is to get granular. And that connects to what I mentioned regarding the ability to really dig into a metric and go all the way to the most granular low-level labels. So for instance, if I mentioned that Coralogix analyzes events, if I just measure the average time it takes me to analyze an event, I may have a metric that is not very useful. So imagine I see that it's 2 nanoseconds instead of 1. The ability I have now to dig into the data and really understand what causes it is very limited, because we have thousands of customers sending from tens of thousands of applications and tens of thousands of sources. But what if I label this metric in a granular way? So instead of having one metric, give me the event process time per customer, per cluster, per service, maybe per data source or application. And that way, imagine now I have an incident of lag or anything else in my metric. I can really go and dig deep into the problem and say, this particular user or this particular customer of mine that works on this particular cluster sends this sort of log, and this sort of log is slowly processed. And that's why the load times are, the processing timers are slower. And it's very easy for me now to isolate and solve the issues. I'm going to still maybe need the logs and the traces. It doesn't make them obsolete, but it makes my usage of them a lot more efficient. Linking to business impact is critical. So you don't want metrics that, they shoot alerts and it's not very clear how those alerts affect your users or your business. So if I talked about our example of processing time of event, our metric will also represent whether that processing time, that long processing time, is going to cause a lag in the data infrastructure and how the data is being viewed by the user. So let's say the processing time went from 1 nanosecond to 5 nanoseconds. I'm also going to see in my metric that this will result in 3 minutes delay of data available to the user. Linking the business impact allows us to harness the organization to solve the problem faster, and also to communicate with the customer-facing departments within the organization on how technical matters affect their users, their revenue. Linking infrastructure with application is critical. So when we look at metrics, we want to have a single dashboard that shows both the infrastructure, network, CPU, memory, and the business metrics. So if I have slow load times, like our example, I also want to make sure that infrastructure metrics during that time make sense. Otherwise, it's very easy to link scale or other infrastructure issues that I have to this applicative error. Visualize long-term. We see so many companies visualizing for just a month, for instance, and then you can see a drift. So it's very hard to look at every single piece at a time and know if it's a good or bad metric. But if you visualize the data, for instance, for 12 months, it's very easy to see how version upgrades and changes that you do affect the long-term trend. Obviously, we want load times to go lower, CPU per user or per company or per resource to go lower. We want processing time per event to go lower. And when we track over a course of 12 months, we can see whether the trends are moving the direction that we desire, or there's something that we're missing and may require our attention. And annotate, which kind of connects to what I just said about visualizing long-term. Always annotate important events, version upgrades, new campaigns, new clusters, new configurations. Anything that you do, you want to annotate it on that long-term graph, so you can not just see the correlation, but also go to the cause and understand what specifically had caused a trend of slower response times or anything else that you're tracking. When we look at tracing best practices, first of all, tracing is extremely chatty. If you implement it across all your applications, it's going to be slow and very expensive. So what you want to do is to identify the high value transactions, money transactions, user signups, permission transactions. Those are the things that your users are most sensitive to, and you want to track. Remember now, Tracing is an instrumentation that adds the context, gives you the span and the trace, and shows you exactly how much time you spent in each and every of the services. You want to do that for transactions that matter for your organization. Tracing is very pinpointed to a specific transaction. You can't, it's not like logs where you can extract long-term stats and ratios and high-level insights. You really get granular, and that's why you want to only identify the high-value transactions and track them. You definitely, along those high-value transactions, a lot of the data will be of the ingress and egress. So just like we were tracking APIs with log data, we want to look at where the data is leaving our microservices and entering our microservices, because this is the time, exactly the time that we want to measure. We want to make sure that it doesn't spend too much time in one of the services. So when we know when it came in and when it came out, we know that this microservice is solving a transaction or a function that we're running. And just our advice here, that goes maybe against a vendor in the space. We suggest our customers to work with a vendor neutral integration. Open telemetry is now extremely better than what it used to be a couple of years ago for tracing. It's pretty mature. It has contribs from all the leading vendors. Once you do that, it's very easy to switch. It's very easy to integrate, and it's very easy to use a couple of vendors in parallel. When you use an agent specifically for something with such deep instrumentation like tracing, you may create a vendor lock that you probably want to avoid. There are other open sources, by the way, for tracing. Look for them. We really see open telemetry as the future of tracing. Now, once we have our pillars of the logs, metrics, and traces set up, we want to start creating alerts, right? We want to become more proactive. There are a few types of alerts, and this is just an example of how we do things here and how we think that alerting should be done to get efficient on-call rotation. First of all, alerts should be defined in a very specific and explicit way. So, we see a lot of customers defining alerts on stuff like more than 1,000 errors in an hour. This is, definitely something you want to track. It's under the umbrella of known unknowns, but you have to be a lot more specific, because if I get an alert on 1,000 alerts and each and every on 1,000 errors and each and every error is different, my ability to really understand what happened there is quite limited. But if you give me an alert that is very specific, that says more than 100 users failed to transact a money transfer within the past hour in our AWS Mumbai region under this service, that will be an alert that is, first of all, linked to business, and second of all, easy for me to isolate, look at the right logs, metrics, and traces, and resolve. There are a few different types of alerts that we're seeing. The first one is immediate. So whenever you see an event that matches my criteria, immediately alert me on it. Typically, if we go back to how we categorized severity of data, that will be a great fit for critical or fatal logs. We have very few of them. They only represent critical situations. We don't want to wait. The minute you see them, send me an alert, wake me up. I want to fix it. Another type of alert is overactivity. That kind of connects to the previous example. More than 1,000 errors of some type in some service in some sort of time frame. That's for me an overactivity of this sort of error for this time span, and very informative to understand that there's a problem in production. Now I need to still read the logs, understand business impact, communicate back, look at relevant metrics, but overactivity alerts are a good way for us to avoid false positive, or if they're properly tested before the fine. Underactivity alerts are the ones that give you the highest level of proactivity, because they alert on typically maintenance and housekeeping stuff that didn't happen. So for instance, if you have a table cleanup, or if you have a batch process that runs every day, you want to create an alert that tracks that particular cleanup or process and alert you if they don't happen. Now, imagine getting this alert. If you get an alert on database cleanup that doesn't happen, the database is not going to get full immediately. You actually have hours or maybe days before the alert actually becomes an incident. So now you can be a lot more proactive, and it's fairly easy to define those alerts. Alert on business logic metrics. So I've described a few examples, but for instance, a business logic metric, a simple one, would be a load page. How long does it take my customers to load a page? I want to track that. I want to make sure that they get great experience. And I want to do that by customer, by region, by URL, and so on and so forth. Infrastructure metrics alerts are fairly simple and been here for a while. I want to get an alert on CPU or memory or threads or network in or network out. Those things are fairly simple to define. And some algorithms there can make them more accurate and reduce some false positives. Remember always to label them. High CPU doesn't mean anything if you don't measure it by resource, by pod, and so on and so forth. And then you want to have the proper organizational structure to handle alerts. So for instance, what we do here in Coralogix, there are different groups. There are a lot of developers, and each group has what we call CX product. It's an area of the product or a full product that they maintain. So everyone does on-call, but the CX product team that is related to the product that triggered an alert will always be the backup for that alert. And everyone knows who's responsible for that and for them the alert if they can't handle it themselves. So once you have that, that team is also responsible for building runbooks and Confluence pages to help people monitor those alerts. Obviously, remember, they have an interest that documentation will be very good because they're always second to the first responder. So if the first responder can't solve it, they'll always go to the internal group that has responsibility over this. This way, you both create full on-call rotation for the entire organization instead of people having to do too many shifts, but also make sure that it doesn't reduce the quality of how you're handling those alerts. And then the last one would be whether to push or not to push alerts. Everyone talk about alert fatigue. There are many ways of handling it, but the easiest one that we found for push notification is a bit of training. Like if you use your imagination here, imagine you're waking up to that alert. And there are three things that you may do. If you woke up at 3 a.m. And got an alert on your PagerDuty or OpsGenie and so on, you're going to respond either by just shutting off your phone. And if that's the case, just don't create that alert at all. Looking at it in the morning, and in this case, create the alert, but don't push it. Just have a review for the alerts that trigger during the night every morning. Go through them, see if something abnormal happens, see if something that can evolve to something serious happen. And you may just wake up, wash your face and sit on the computer to resolve the issue. That is the only reason for you to define this alert. So once creating the alert, think about it. If I was to receive this alert in the middle of the night, would I wake up actually and remediate immediately? Or would I look at it tomorrow or just slam the phone and go back to sleep? So that's how we think about proper alerting and making it more proactive. And then, of course, that's what we call the fourth observability pillar. So everyone talk about logs, metrics, and tracing as the observability pillars. We think that if you think broadly of the word observability, you cannot say you have observability into your environment if people can walk in and out, steal data, send data outside, and so on and so forth. And so we see how dev and ops, obviously DevSecOps is a huge term, how they collide. And once they collide, the tools need to provide the synergy of data, because we believe that every log is a security log, because access logs, ELB logs, S3 logs, and so on can be used both for operations and application monitoring, but definitely for security. Whoever broke into you went through the load balancer. Whoever has done anything on machine left some infrastructure logs as evidence. So there's synergies between security information and monitoring information that we think that are going to become more and more apparent. And we're definitely seeing a lot of companies doing that move, both observability and monitoring companies that became also security companies, but also the other way around. A couple of the largest EDRs, XDRs in the world actually acquired observability and logging companies and made them into their data platform, because it's all a game of data after all. And last but not least, the Coralogix way. So we believe that by parsing enriching, detecting anomalies and so on in the stream, including stateful stuff that look at long-term trends instead of indexing everything and only then analyzing it, is more scalable and a lot more cost efficient. And so our customers can choose whether they want to store the data for frequent search, just keep it for monitoring, detect any alert, visualize it, look at it live, or if they just need it for compliance. And all data is stored on their own remote storage, and Coralogix can query that data remotely at no cost, or rehydrate, reindex that data if they need to frequently search it. And that way, by reducing costs for the different use cases, so frequent search will be full price per unit, and then monitoring data is 60% discount, and then compliance data is 85% discount. Our customers typically get 70–80% lower cost, which helps them increase coverage. But more than that, look at the data in more real time, higher performance, better scale, and they can plug in whatever tool they already have in their ecosystem. So we support over 10 different dashboards and 5 syntaxes because we're not dependent on any storage or storage schema. That's all for today. If there are any questions, feel free to reach out and visit Coralogix.com. You can send an email to our info@Coralogix email for any questions that you'd like or further elaborations on this presentation or Coralogix. Thank you very much.